So this is the assignment which we have to do, and it's basically a fin plate connection in which there's a main beam, which is IPE 500, and there's a secondary beam, IPE 300. It's just that the IPE 300 is skewed, so it's moved in the X direction by 2 meters. Instead of being 90 degrees like that, it's moved 2 meters in the X, and it's also raised by 1 meter. So it's coming at it's a skewed fin plate connection. Now, there's a fin plate, obviously. This is the fin plate. It's going to come in, and the dimensions of the fin plate are given. And then there are two stiffeners, the top stiffener and the bottom stiffener. So the top stiffener dimensions are given, and the bottom stiffener dimensions are given. If you notice, they are slightly different from one another. The bottom stiffener is slightly longer. It's 237.7, whereas the other one is 228.2, and that's because they are hitting the edge, whereas the one as you go down, you need to traverse a longer distance to get to the point, get to the edge of the fin plate. So this is the assignment which we have. Let's see, you can see the notes over here, which I've just summarized for you. So let's start to let's see what we can do about it. Now, one thing we notice over here is that the secondary is approaching the main, and it's cut vertically at a distance of 20 millimeters from this face of the main beam. And secondly, if we look at this detail one, we see that there is no clash between the fin plate and the web of the main. So if you zoom in, you see this point of the fin plate is touching the web, and the other point is away. So there's only one point of contact over there. And the same with the stiffeners. The stiffeners are also not clashing with the web; they're just touching. Because they're inclined, there's one touch point, as you can see over there. We just note these things, we keep this in mind, and we go to the model. Now, I've already created the main and the secondary. So this is the main, this is IPE 500. The other one is IPE 300. I have moved the IPE 300 2 meters to the left and 1 meter in the Z direction. And let's start modeling it. So the first thing which we can do is actually create the cut, which will pull back the secondary. So we can just look at it from the top. Zoom in over there. Go to our edit menu, go to plane cut by surface. We can select this to be the part which needs to be cut. And the cutting surface, we try to hover over it, but it's selecting the top one. So whenever it does that, I can just keep my mouse over there and click on the control key, which will toggle between the surfaces. So I click on control, and you see it's toggled to the side surface, and I just click it, and that will just give me the cut over there. Now, if you notice, the cut is exactly at 0. So what I can do is I can select that, press enter, double click on the cut over there, and I can use this distance over here and give it a distance of -20. This is position depth offset, and when I do that, you see that it's pulled back by 20 millimeters. I can measure the distance like that, from here to here to be 20 millimeters. So that's the first hurdle out of the way. Now, whenever you have this kind of a connection where there's a plate which needs to go in and match up with the web on one side and the face on the other, this web on the other, it's actually quite simple. And you can start off. Let's turn off the cuts so that they don't get in our way. And we can go to the steel menu and go to sectional plate, and under that over here we have this create plate on surface. Now what this will do is that when we click on it, it will ask for a surface, and the moment we select a surface, it's going to create a plate on that surface. So you see it's created a plate on that surface of the web. Now the fin plate in our case, if I go back, is 12 millimeters. So I go back to the model, I double click on this plate, and I make it 12 millimeters. Don't worry about the shape of the fin plate at all right now. because I will be modifying that shape. Now, if we come back to the drawing, we see that the fin plate is 55 millimeters from the top of the secondary and also 55 millimeters from the bottom of the secondary. So we quickly get these offsets corrected. Go back to the model and we select this the fin plate, which is just it's just along the web right now. Nothing is correct about it except for that. And we just select this top edge and we give it a on the surface we say 55 millimeters positive because it's from the top. The outer unit normal is pointing upwards, so we can give a number of minus 55 over here. So let's select the surface and say this top surface like that, and you can see that it has been pulled back 55 millimeters from the top surface. And we can do the same for the bottom surface. Select that and select the bottom surface like that, and it's been pulled back. So the fin plate is now correct as far as the distances from the top and the bottom are concerned. Now what we can do is we can very quickly take this edge and give this distance as 0 and let it go and stick to the web of the main. We say select surface and we select the web of the main, and immediately the fin plate goes and it sticks to the surface over there. So now it's almost done actually. All we need is to reduce this length of the fin plate. The top is 55, the bottom is 55, this end is sticking to the web. And for that, we go back to the drawing and we see that the fin plate distances are 248.6 at the bottom. The bottom distance is 248.6, and the top, which is shorter, is 218.6. So just keep those in mind. Let's start with the bottom. It's 248.6. Go back to the model. We just select this one, and this is the bottom one. So we click on this and we say 248.6. And the pink one needs to move back, so we click on the pink one. And then we go back to the drawing again, and the top one was 218.6. Come back to the model, click on this one, 218.6. This time the yellow one needs to go back, so we click on that, and suddenly we have the fin plate which we want. So we can check that 218.6, 248.6. This distance is 190. It's 55 from there, 55 from there, and this end is sticking to the web. And we can quickly do a check of that clash as well. Press Alt-D, zoom in, and you see that it is perfectly placed. One edge is touching, and the other one is not. So very quickly, without worrying about the shape, we have managed to create the fin plate. And this is something which we can do often. Which we do often with manual connections. You initially start off with just a shape. It's a square or a rectangle or anything basically, and then you can quickly say make this edge go and stick to that point, make this edge so many millimeters behind that point, or make this length so much, and that will bring you to the desired shape with just a few clicks. Now we get back to the drawing and we focus on the top and bottom stiffness. We're going to make the top one first. You will see that we won't need to worry about these dimensions because they'll just come out automatically. It's the 20 millimeters and the 74 millimeters which we'll need to adjust, and these ones. So the top stiffener is 65 millimeters from the top of the fin plate, the middle of the stiffener, and then there's another 60 for the second one. So let's try to create the top stiffener first. This one, which is the shorter one slightly. Just remember, we'll come back to these numbers, and like we did with the fin plate, we'll start off with something just a square, and then we'll modify it. So just keep this 65 millimeters in mind. So we go back to the model, and what I do is I right click and I put my work plane to the outer face of that fin plate, and I just start creating a stiffener from here to here, and then from there I just make it come out in the Z direction, the DZ50, any number. Don't worry about numbers right now. Click on that, DZ50, and then zoom in and just close it, and we have a stiffener like that. And I can immediately double click on it and reduce its thickness to 8 millimeters, and maybe even change the color so that it's easier to distinguish from the other one. And then I remember that this one was, let's go back to the drawing, it was 65 millimeters from the top of the fin plate. So what I can do is, this being the Y direction, I can just select that, say move linear, and say reset over there and say minus 65, like that. Now it's in the correct place, but the shape is obviously wrong. It's not a square rectangular stiffener. But what I can do immediately is I can select that, and I can select this edge, and I can say you go and touch the surface at the back. So that's one obstacle out of the way. And once I get that correct, I know that this length needs to be, so we go back to the drawing, we know that this length over here, which is along the web, is 74. And this one over here is 20. Those are the two numbers I'm focusing on. This 74, which is at the back, and this 20 over here. So I just select this, and I click on this one, 52.8, and I make it 74 in the yellow direction, like that. And I select this little 50 over here, and I make it 20 in the pink direction, like that. And you will probably see that the other numbers have automatically sorted themselves out. So for example, this is 228.2. So you can see this 228.2 has sorted itself out automatically, and the other one should be something like 210.6, I'm hoping. Yeah, there you go, 210.6. So just by making this one 74 and making this one 20, the others have sorted themselves out. And the other fin plate is 60 millimeters below that. So I can go back, and I can select it, say copy linear, and say minus 60 below that, like that. And once again, because it's now going to be away from, because I'm copying along that direction, so it's basically copying like that. So this one is not touching now. So once again, all I need to do is select it, make sure this one goes and touches the back surface, like that. And once I do that, basically I've got this one 20. This one needs to be corrected, 76, but this one also needs to be 74. Make it 74 in the yellow arrow direction, like that. So this one is 20, that one is 74. Let's see if the others have sorted themselves out. This one, the back side is 237.7. So that's 237.7, and this one is 219.8. This one is, let's see, this one is 219.9. The other one is it's probably close enough. So we've managed to very quickly create the stiffeners in there, and now all we need to do is just focus on the bolts. Now we get back to the drawing for the bolts, and we see that the holes are Phi18, so they're M16 bolts probably, and they're offsetted by 25 millimeters along this direction and 35 millimeters inside. So and then we have the distances 60, 60 in that direction, 50 in the other direction. So we go back to the model. Just remember 25 and 35. Go back to the model. Go to our bolt commands with the auto coordinate system, because a plate is involved. Click on that, select the fin plate, select the secondary beam, right click. And you can start off by any one of these. Start off with this as the origin, and or you could just give a direct entry offset as well. I'm just going to move it in that direction. I'm going to move this, I'm going to say move linear. In the X direction, it was minus 25, and the other direction, it was minus 35, if you remember, like that. So the bolts come at that point. If you recall, it was M16 bolts with a tolerance of 2 to get V18 holes. And then if you go to the positions, the distance in the X direction was 60, 60. So I need another 60. And in the Y direction, it was 0 and 50, I think, like that. So basically that's it. We have our holes, we have the bolts inside as well. So what seemed to be a pretty complicated kind of a connection, all skewed and raised and lifted and offsetted and everything, we can quickly go and check how the stiffeners are doing. See that they're also not clashing. One point is touching and the other point is not. This one also, one point is touching. And we've quickly managed to create a reasonably complicated connection by not worrying about the initial shape of the plates. That's very important. Whenever you're doing a manual connection with well-defined lengths and angles and everything, don't worry too much about them at the beginning. Just get a square plate inside somehow very quickly. And then just by selecting edges and corners and doing the kind of stuff which we did over here, within a few clicks, I mean, I've been talking most of the time, but if I were to not talk and just create this, it'll probably just take maybe 5 minutes or something or less, because it can be done really quickly with these handles. This handle goes to 55 from there. This one goes to 55 from the bottom surface. These lengths can be adjusted to any length we want. This one sticks to the web, and we just create the initial stiffener over there as a rectangular one, move it down, and then just change 2 numbers and everything else fits in. Just copy it down, move one edge, and just create the bolts. Each individual one of those actions will can probably be done in a minute. So we created 5 things: the cut, the plate, the stiffeners, the 2 stiffeners, and the bolts. It can probably be done in about 5 minutes. So a nice example, a nice assignment to get used to this kind of manual modeling, and you will be using these techniques a lot.